Now, let's look through another example that we can do for this quadratic sequence. Now, if you haven't go through my previous video where I explain in detail on how to do quadratic expression, you can go through that first and then you can come back here later. Okay? But let's work together on how we solve this quadratic sequence here. So my question here is I want to find the n-term rule of this quadratic sequence. So how do I know if this is a quadratic sequence? I have to find my second difference. Right? If my second difference is the same number, so I know that this sequence is a quadratic sequence. So let's work that out together. So here to here, the first difference I should get -1. This one I should get -2, -3, -4, and over here should be -5. Okay, so this again tells me it is already not a linear sequence, so it can be a quadratic sequence, right? So we have to check for the second difference. So if we check for the second difference, you will notice everything in the second difference, it's -1. Okay, so like over here, I already make a rule that if the sequence have the same second difference, the sequence is a quadratic sequence. So the second difference are all -1, they're the same number. So which means this is a quadratic sequence. So if you want to find the n-term rule, we can apply this formula over here. Okay, so again, the n-term rule of a quadratic sequence is written in this way: an squared plus bn plus c. So all we have to do is to find what is the value of a, b, and c and substitute that inside the expression and we are done. So how do we find a? We will do this one by one. We will start from the bottom to top. Why bottom? Because there's only one unknown here and it's easy for us to find that first. Okay, so let's start to find a. So for my a, it's going to be 2a is equals to the second difference. So 2a is going to equals to the second difference. So this is my second difference. So this time is going to equals to -1. Alright, now if you work this out, a is going to be -0.5 over here. Okay, so I'm done with my a, so I'm going to do my b right now. So to find my b, I'm going to use 3a plus b, and that will be equal to the first number of the first difference. So in this case, that will be -1. Okay, so I will solve this right now. So my a over here, that is -0.5 plus b, and that will equals to -1. Expand this, I should get -1.5 plus b, and that will equals to -1, and is equals to -1 plus 1.5, which should give you 0.5 over here. Okay, so we have find the value of b over here, and lastly we just have to find our c. So to find our c, I'm going to use the last formula over here. That's going to be a plus b plus c, and that will be equal to the first number of the sequence. So in this case, that's going to be 25. Okay, so since I already found my value of a and b, all I have to do is to substitute here. So a is going to be -0.5, so that will be -0.5 plus my b, that's going to be 0.5 plus my c, which is the unknown I'm interested to find, and that's equals to 25. Okay, so if you notice over here, these two will cancel each other, right? So what's going to left is going to be c is equals to 25 over here. Okay, so with that, we have already found our value of a, b, and c. So finally, we can substitute back to our quadratic expression over here. So in the end, I have an squared plus bn plus c. Okay, so all I have to do is to put in all my values of a, b, and c now. So my a over here, that's going to be this, so it's going to be -0.5 n squared plus my b, that's going to be 0.5, and then plus c, which is only going to be my 25. Okay, so after that, just expand everything. Okay, put everything nicely, so your final answer should look like this: negative 0.5 n squared plus 0.5 n plus 25. So this over here, all right, that will be the n term rule. All right, that will be the n term rule of this quadratic sequence over here. Okay, now again, if we want to check if this is correct, we can work this out very quickly. Okay, you can just check one of the term that you are interested to find. So let's just say I'm interested to find this one. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So that will be t is equals to 6. So I'm going to replace all my n's with 6. Okay, so if I replace all my n to 6, I expand everything, I should get 10 over here. If I get 10, which means my n term rule is correct. Now I will strongly suggest this because this one is a quick way to make sure that your answers are correct. So 6 squared, that's 36, okay? 36 multiplied by 0.5, negative 0.5. Over here, that should give me negative 18. And over here, I have 0.5 times 6, that should give me 3, and then plus 25. So if you work this out very quickly, negative 18 plus 3 plus 25, and true enough, this should give me 10. Okay, which means that this n term rule is correct for this sequence over here. Okay, so I hope with this you have understand how to find the n term rule of a quadratic sequence. Okay.